So this video will walk us through section 4.5, which is on conditional probability. And so we have started with basic probability in 4.1. Then we talked about different events, including mutually exclusive events. Then we did rules of probability, specifically where we talked about adding probabilities together. If it's like the probability of A or B is the probability of A plus the probability of B. And if they're events that are not mutually exclusive, then you have to subtract the intersection or the AND of A and B. And then yesterday we talked about contingency tables and how you change those contingency tables to joint probability frequencies that has marginal probabilities along the sides and the bottom. So today we're going to move on to conditional probability. So we're just getting more and more stuff thrown at you here. See if you can follow along, and then we can do assignment 4.5 in Math Excel. So conditional probability is defined as an event occurring B given that another event A has occurred. That's conditional probability. So we denote it with this notation right here. So you really need to put this in your notes. We read that it's the probability of event B happening given that A has already happened. So a real quick example of something like this would be this. Suppose we roll a simple die. When we do that, we can get 6 different answers, 1, 2, 3, 4, 5, or 6, or 6 different outcomes, 1, 2, 3, 4, 5, or 6. So if we let F be the probability or the event that a 5 would be rolled, and O be the event that a die comes up with an odd number, then we want to find these 3 things. The first thing is the probability of F. So it's denoted like this. The probability of event F happening would be 1 out of the 6 different possibilities. And so we would just take 6 different possibilities because we have 6 different outcomes that could happen, only one of which is a 5. So we would take 1 divided by 6, which is 0.16 repeating. So the probability for F would be equal to 0.16 repeating. Well, now let's get into conditional probability. So if we move on to part B, this is read the probability of F given that O has happened. So remember that O is that the event that the die comes up odd. Well, there's a 1 that's odd, there's a 3 that's odd, and a 5 that's odd. And so there's only 3 possible events that are odd. We know it's one of those 3. And of those 3, how many are event F, which is the 5? Well, that's 1 out of the 3. So the probability of F, given that we know it's odd, is 1 out of 3. And 1 out of 3 is 0.3 repeating. Okay? So we have, this is the answer for part A, this would be the answer for part B, and then this is where it gets kind of complicated. So we're going to move on to part C. We want to know the probability of O if it's not F that occurred. Well, if F is that 5 was rolled, not F would be all the other 4 possibilities, specifically the 1, 2, 3, 4, or 6. So there's 5 specific outcomes for not F. Okay, so if that has happened, how many of those 5 outcomes would be O, would be odd? Well, of those 5 outcomes, 1 is odd and 3 is odd, and that's it. So it's 2 out of those 5 outcomes. And if we take 2 divided by 5, we're going to get 0.4. And so that's the probability of O given that F did not occur, or not F. Let's move on and take a look at some other situations. It says use the table on the next slide to find the following probabilities. First, it's an unconditional probability, but we want to find the probability that a selected faculty member is in his or her 50s. So if we take a look at this contingency table, we want to find the probability that a professor is in his 50s. Well, this is not a conditional probability. We have this column right here of people that are in their 50s, and that's a total of 253. So it's going to be 253 professors out of the total number of professors, which is 1,164. And so we could divide that out. We could take 253 divided by 1,164, and that is 0.217. So if we go back here, this is going to be 0.217. Or if we wrote it as a percent, 21.7% of the professors are going to be in his or her 50s. So now let's take a look at a conditional probability. The conditional probability that a selected faculty member is in his or her 50s given that he or she is an assistant professor. Okay, so let's take a look at this. Given that they're an assistant professor, so we're only talking about this column here. Given that they're in that column, that's a total of 320 people. So we know that it's one of those 320 people. We want to know what is the probability that if they're in that 320 people, how many of those are in their 50s? Well, the 50s would be this one right here. 36 out of those 320 people are going to be professors in their 50s. And if we take 36 divided by 320, that gives us 0.1125. And so the probability here is 0.1125. Or if we were using percents, 11.25% of the assistant professors are in their 50s. Okay? That's probably because by the time they're in their 50s, they're either changing to another profession or they're going to be like an associate professor or a full professor. All right? So let's take a look then at a different way of thinking about this. There is a formula for conditional probability. And this is a formula you probably want to put down in your notes. The probability of event B given A, we can find always using this formula, where we take the probability of event A is on the bottom. That's the given amount. That's always on the bottom. And the probability of both events in the numerator. So the A would be on the bottom, and the probability of both of them together would be in the numerator. Let's take a look and see how we would do that with our last question. We want to find the probability of A4 given R3. Well, I'm going to go to this. I'm going to go back to this table that we're working with. We want to find the probability of, let me write it over here. It's the probability of A4 given R3. Okay? So what we're going to do is put the R3, we're going to use the formula for this. Remember, the formula here is this. The R3 is the denominator. Okay, so we're going to have, in the denominator, we're going to have the probability first of R3. Oops, that is R3. The probability of R3. Sorry, so sloppy. So I'm going to go back and look at the probability of R3. Well, that's this right here. That's the people we're talking about. Okay, so in the denominator, we're going to have 320 people. So that's the given part. So the given part is that they're an assistant professor. Okay, it's 320 people. Then in the numerator, we're going to have both of these. So the probability of A and B is in the numerator. So we're going to have, specifically in this case, the probability of A4 and, okay, so and R3. Man, is this messy. Hopefully you guys can read this. Okay, so I'm going to go back to the slide. A3 or A4 and R3 is right here. That's the numerator. And so the probability of A4 and R3 is 36. And if I divide 36 divided by 320, I'm going to get the same thing that I had here, which is 0.1125 or 11.25%. Okay, I'm just going to write it out as 11.25%. That's how the formula works. Okay, and the formula will work all the time. Let's take a look at a different situation here. So here we have males and females. Singles would be guys or girls that have never gotten married. We have ones that are married, ones that are widowed, and ones that are divorced. Okay, and this is a joint distribution table because it doesn't have the frequencies. It's not the actual numbers. It's the probability of each of those. So let's use this distribution table to answer these questions. The first one, determine the probability that an adult selected is divorced, given that the adult selected is male. So this is the given. That's what we're working with. That's going to be the denominator. So our denominator, let me just put this one up here. The denominator is S1. That's this right here. So that's going to be 0.485. 0.4. Oh, I didn't want to do that. Let me go back here. Okay, so it's going to be 0.485. I can't even write it on anything here now. Let me try this again. Okay, so in the denominator it's going to be 0.485. All right, then I want to find the numerator, which is going to be both of these, M4 and S1. Well, here's S1 here, here's M4 here. This is where they come together. That's going to be 0.044. Okay, so to find this conditional probability, I am going to take 0.044 divided by 0.485. And that gives me 0.09. 0.0. Gosh, did it again. 0.09. Okay, and that's what the answer to the first question is going to be. Okay, which is 0.09. It actually goes on a little bit longer than that, but we're going to stick with that. And then the next question here is this one. Determine the probability that an adult selected is a male given that the adult selected is divorced. Well, so given that they're divorced, this is our given right here, which is M4. Okay, so we're just going to look at M4 here, which is this one here. That is the denominator of 0.104. The numerator is going to be where both of these happen. That's S1 and M4, which is 0.044. So I'm going to take 0.044 divided by 0.104, and that's going to give me 0.42. So 42, really 42.3. So 42.3% of the people who are divorced are males, and if I go up to the top one, 9% of the males are divorced is the first one. So this is what conditional probability is like. This is what our homework assignment is like. Now you have the rest of the period to work on it, and hopefully by Monday we can have a good idea of what this looks like. We'll go over questions that you have not only on this assignment but on the last one. Good luck, everybody. Have fun, and we will talk to you on Monday.